Hello everyone. Today, we're diving into the exciting world of R programming, an essential tool for data science. R is indeed a powerful tool, specifically designed for statistical computing and comprehensive data analysis tasks. Let's begin by understanding what exactly is R programming and why is it so widely used in the data world. R is an open-source language, perfect for statistical computing, data analysis, and creating beautiful graphs, developed by Ross I. Haka and Robert Gentleman. Now, let's walk through the essential steps to install R and RStudio on your computer, getting your environment ready. Setting up your R development environment correctly is crucial, ensuring you have all the necessary tools to begin coding. First, you'll need to download the R base system from CRAN, which is the comprehensive R archive network. Once downloaded, simply run the R installer file and follow the on-screen prompts to complete the installation. Next, download RStudio Desktop, which is an integrated development environment that makes R much easier to use. Similar to R, run the RStudio installer, accepting the default settings to ensure a smooth and complete setup. Finally, we'll verify the installation of both R and RStudio to confirm everything is working correctly. Let's specifically look at how to install R on a Linux system, and then verify your RStudio installation. We'll cover the necessary commands for Debian-based Linux systems and how to check your RStudio setup. The first logical step is to update your system's package list, ensuring you have access to the latest software versions. You'll achieve this by running the command sudo apt update in your terminal, which fetches new package information. Next, we'll proceed to install the R base package, which is the core R programming environment. To install R, simply execute sudo apt install rbase in your terminal, then confirm the installation when prompted. Finally, we'll check the RStudio version to confirm it's correctly installed and ready for use. Within RStudio, you can type version into the console and press enter to see details about your R and RStudio versions. Welcome to our exploration of R, where we'll delve into the powerful R package ecosystem, a core strength of this language. So, what exactly are packages? They are collections of functions, data, and compiled code that extend R's capabilities significantly. First, you need to know how to install packages, which involves downloading them onto your system for future use. Once installed, you'll learn how to load these packages into your current R session to access their functionalities. Finally, we'll cover how to effectively use the various functions that these packages provide for your data analysis. Let's now move on to the practical aspects of installing and using R packages, a fundamental skill in R programming. We'll explore the essential functions that are crucial for efficient package management within your R environment. To begin, let's understand how to install packages, which is the first step to expanding R's functionality. The install packages function downloads and installs packages from repositories like CRAN, and you can install multiple packages at once. These code snippets demonstrate how to install a single package, ggplot2, or multiple packages like dplyr and tidyverse simultaneously. After installation, the next crucial step is to load packages, making their functions available for your current work. The library function loads an installed package into your R session, activating its tools for your immediate use. Here, you see how to load the ggplot2 and dplyr packages, enabling you to use their powerful visualization and data manipulation tools. Sometimes you might need to remove packages from your system, which is also a straightforward process. The remove packages function allows you to uninstall a package, freeing up space and managing your R library. This code shows how to remove the ggplot2 package, effectively uninstalling it from your R installation. Now, let's explore the core pillars of R programming, which form the foundation of all your data analysis tasks. These fundamental concepts are the essential building blocks that you will use for every aspect of data analysis in R. First, we have data types, which classify the kind of information R can work with. These include numeric, character, logical, and complex values, each serving a distinct purpose in your data. Next, we delve into data structures, which organize and store your data in various formats. Examples include vectors, matrices, lists, factors, and data frames, each suited for different data arrangements. Control flow is another pillar, dictating the order in which your code is executed. This involves conditional statements and loops, enabling logical and repetitive execution of code blocks. Functions are also a critical component, allowing you to encapsulate and reuse code. They are reusable blocks of code designed to perform specific tasks, making your scripts more organized and efficient. Finally, we have packages, which significantly extend R's base capabilities. Packages are collections of functions and data that provide specialized tools, greatly enhancing R's analytical power. Let's put some of these concepts into practice by looking at basic R commands in action. We'll focus on performing fundamental arithmetic operations and assigning values to variables, which are core R skills. Starting with basic arithmetic, R can act like a powerful calculator for your numerical tasks. You can perform calculations like addition, subtraction, multiplication, division, and exponentiation directly within the R console. Next, we'll cover variable assignment, which is how you store information for later use. You can store values in variables using the left arrow assignment operator, written as for future use or manipulation. We'll also explore using functions, which are pre-written tools to accomplish specific tasks. You can call built-in R functions, such as sqrt, for square root or mean, for average calculations to perform common operations. Lastly, printing results is essential for seeing the output of your commands and understanding your data. You can display the output of commands or variable values clearly using the print function in R. Let's quickly recap what we've covered in our introduction to R programming. This summary will highlight key points. Here are the most important takeaways and essential points you should remember about R programming from this session. Remember, R is a powerful, open-source language specifically designed for statistical computing and comprehensive data analysis tasks. For installation, you'll need R from CRAN and the RSTUDIOIDE, which provides a much better and user-friendly development environment. Packages significantly extend R's functionality, and you manage them using the install.packages function to install and the library function to load. We learned that basic R commands involve performing arithmetic operations, assigning values to variables, and making function calls. Ultimately, R programming relies on fundamental concepts such as various data types, different data structures, and essential control flow mechanisms.